the simplest term is we call it coil. Okay, coil because um, something like this. Okay, so it has inductance. Inductance means it determines the strength of magnetic field around a coil. Okay, so that's inductance, measured in Henrys or HK. So as much as capacitor has its own capacitance measured in farad, so inductor also has its own unit, inductance, which measure the strength of magnetic fields around its coil, and it's called Henrys. Okay, so of course the constructions of inductors and etc. You can see in the textbook, all right. But normally the symbol use is like this. If let's say this is a circuit, so it's just like that. Okay. Now, oh, sorry. Okay, so definition uses simpler explanation of inductors. So the main thing is on this induced voltage. Let me see. Okay, so the induced voltage is the inductance times the amount of change in current. Okay, I over dt. So if the current changes rapidly, the induced voltage is also increased. Okay, this is the induced voltage. So okay, so for example, among the use of inductors or the concept of coil, if you still remember, I'm not sure if you've learned about transformer or not during your SPM or foundation. So something like, okay, you have number of turns here and number of turns there, which inducing voltage across this region. Okay, so this example of the use of the concept of inductors. Okay, right. So in here, the larger the inductance, okay, the more rapid the changes in the current, the larger the inductance. Okay, so if this one goes high, this one goes high, obviously the larger will be the induced voltage across a coil. Okay, so right. So similarly, yesterday, I'm not sure if I mentioned it to you. Similarly for, so this is, if I can write it here, this is inductors, right? So we have yesterday we should have this capacitance. Okay, so similar to inductors. So this is capacitor. Okay, so the higher the capacitance, the higher the change in the voltage across the capacitor, which means the higher the current, okay, the induced current. So for inductors, it's also the same. We have VL equals to L di over dt. So that's the basic concept of inductors. Secondly, I would like to touch on the transient. Okay, transient. So transient, if you still remember yesterday, this is initial condition, and so over here is steady state. Okay, it has reached steady state. This is initial conditions, and over here is what we call transient. So in inductors, we have storage phase and release phase. Okay, so if you remember yesterday, for capacitor, we have charging and discharging in terms of electrical field. But for capacitor, it's storing and releasing in terms of magnetic field. Okay, magnetic field because of the coil. Okay, so what else? So in transient, so this is transient, and we reach. So as always, after 5 tau, okay, tau is the time constant. So tau equals to, so yesterday RC, and this time around it's L over R. Okay, so this is our tau. Okay, so tau is in second. So for example, we have um, something like this. Let's say this is 1 ohm and this is 1 Henry. Therefore, tau equals to 1H divided by 1 ohm equals to 1 second. Okay, so that's time constant for inductance. And what happened after time constant? After 5 time constant, it reaches steady state, stabilize. Okay, so inductor becomes short circuit. Okay, so if you have a circuit, okay, this is voltage supply, and you have inductors. Okay, so let's say we have switch here. Okay, so initial conditions. So once the switch closed after 5 tau, this becomes short circuit, right? So and therefore over here IL is at the highest, okay, equals to E over R, right? So this is E, this is R. right? So it makes sense because it's just short circuit, and what you will have is I here equals to E over R in terms of in terms of graph. What you will find is okay. So this is E over R equals to I lah. So at steady state. Okay, this is 5 tau. Right, so it becomes short circuit. So as simple as that. So in terms of so this is I L equals to this one. In terms of voltage waveform at the beginning of the switch here, okay, something like this. This is for VL, okay, equals to E. So at the beginning, we have inductors here and it's open. So therefore the voltage across the inductor is actually equals to E. So over here, so this is 0, T equals to 0, okay. And after steady state, so this is T, okay. V is equal to 0. Why? Because it's just a short circuit here. Okay, there's nothing here, right? So that's during transient process, storing and then releasing the magnetic field. So, and number 3, so if we go back, okay, so the definition uses a simple explanation. Of course, you can read more on this. Okay, what's the use of inductors and etc. And we need to know the transient process, also the steady state. Okay, so it becomes short circuit. And finally, we need to look at the series and parallel inductors calculations, similar like yesterday when we calculate inductance for series and parallel. So interestingly, it's very easy. Series parallel inductance calculation. So interestingly, it is equal with resistor. Okay, equals with resistor. So for example, resistor circuit. So for example, so let's see. I want to see. Okay, so let's say we have inductance. Okay, so let's say this is L1, L2, L3. So total inductance looking from this side equals to, so similar like resistance, so it's just L1 plus L2 plus L3. Okay, so very similar with resistor. So, and also if you have resistor in parallel, let's say, okay, so LT, L1, L2. So this LT equals to what? Anyone can take a guess? So it's very similar um, with resistor. Okay, so oh, sorry. Okay, because it's two parallel resistor, right? So L1 times L2 over L1 plus L2, or rather, if the more classical way is something like this, right? So and essentially it is the same thing, so no need to worry about this. Is this the one? Yeah. Okay, and therefore LT equals to L1 L2 over L1 plus L2, right? So it's the same as above. Okay, so basically that's about it that I would like to cover for inductors. So that's the main thing that you need to know. So let's try one question or one or two questions that I would let you at least understand. I don't want you to calculate the inductors, etc., because you can simply measure it in labs, right? But I will let you to let's try this. So let's see, where is it? Okay, let's try this simple. Uh, wait. So we go here. Let's see. Uh, okay. So let's say you're given. Try to calculate this. Okay, so let's say this is 6 millihenry. This is 14 millihenry. This is 35 millihenry. This is 9 microfarad. This is 10 microfarad. And this is 90 microfarad. Okay, try. We need to simplify this case. So the question is reduce the network. So how do we do this? Okay, so again, don't get confused. It's easy actually. So let me just. Okay, so we can start with, let's say, for L first. Okay, so it's series, so it's similar with resistor, right? And we have 14 parallel with 35. What do you get? Okay, equals to, right? So capacitor, I hope you still remember. Okay, so for capacitor, um, So capacitor dia terbalik kan. So how do I do this? Kalau terbalik dia tambah. Okay, so plus 900 divided by I hope I get it right. Okay, you can try for yourself as well. So it reduces to okay, so this is LT, this is CT. Okay, so I hope you can see, right? So it's just as simple as that. Okay. Next question. So let's try another questions. Okay, let's try. Okay, let's try another example. Okay. So let's say you're given this. Okay. So this is 2 Henry. 2 microfarad. 2 microfarad. This is 60 volt. I1, V1, V2, I2. So the question asks you find the um, find current and voltage after 5 tau. Okay, try first. If you would like to, I give you like 1 or 2 minutes. So you know that 5 tau meaning this equals to steady state. And you know that in steady state, you know that in steady state, cap becomes open, L become short. Okay, try. I give you 2 to 3 minutes to try. How do we do this? Anyone? Nampak tak? So let me try to reduce it. Okay. So the circuit looks like this. The circuit looks like this. During steady state, okay. Right, so okay, so what do you think I1 and I2 would be? I1, I2. Anyone? Usama? Usama?
Yes, Doctor.
What's I1 and I2? Here. Huh?
Stable state, it will be open circuit.
Yes. So what's I1 and I2 in this open circuit? So in open circuit, guys, it's not connected, right? So okay. So 0 amps.
I
Yeah, I 0 amps. Okay, I 0 amps. And how about V1 and V2? V across capacitor. So if you recall yesterday, uh, during steady state, right? Okay, during steady state. So here is steady state, stable, and it equal to E. Okay, so V1 is actually equal to V2 is actually equal to E equal to 60 volt. Okay. Right, so let's try another example so that you get familiar with okay, let's say you have okay, so this is 4 ohm, this is 8 ohms, this is 2 Henry, this is 100 microfarad. Okay, this is the switch, and we want to find what is I2, what is V1 here, okay, what is I1, and what is V2. So find the steady state current and voltage. Okay, so remember, always remember, steady state means, so steady state means it's more than 5 tau. Okay, capacitor becomes open, inductor become short. Okay, try this. What's I1, I2, and V1 and V2? So how do we do this? Again, it's very easy actually. Okay, so steady state. Okay, steady state. This
I equal to 3
I1
ampere.
equal to, yes, I1 equal to 3 ampere, because it's open circuit here, right? So therefore, um, I,
I2 0.
yes, correct. Because I2, there's no current flowing here, okay? And therefore V2 is also 0, right? And this becomes short circuit. And what's I1? So I1 is just, right? So this is just a simple, oops, okay, this just a simple series circuit here with 12 volt and 4 ohms. Okay, so your I1 is here. So I1 is just 12 volt divided by 4 ohms equals to 3 amps. Okay, how about V1? What's V1? Okay, so V1 again is simply 12 volt, right? Because it's 3 amps times 4 ohms. Okay, so that's the whole idea of having this circuit. Okay, so very important for DC circuit. After certain time, we have the steady state condition where capacitor becomes open and inductor becomes short circuit. Okay, so I hope you get the gist of inductors. Okay, like I told you here, like I write here. What I wrote here is this one. Of course, we have to read more on this. The use, the definition, and etc. The transient period and the series and parallel inductance. Okay, so that's it for inductors. So now, any questions before we move on? Okay, so what's important is for inductors, VL equals to L di over dt, and for capacitor, IC equal to C dVc over dt, right? Um, if no questions, Okay, so if no question, so let's go like I promised yesterday. I'm just gonna go briefly giving you some hint or some tips for the final exam paper. Okay. So inshallah you will sit for your final exam on anyone can remember?
31st.
25? 31st, right?
Yes.
Not 25, 25th. Okay. I kind of forget what's the time.
9 a.m.
All right. Venue. Do you have the venue with you?
FPQS.
FPQS. Okay. You will need to find where. Right. So not so much that I'm gonna tell you what the question is all about. It's just that it's a subjective questions. Okay. Um, please write clearly. Okay. If possible, um, uh, new if possible, if you get new question, new page. So whenever you write new, if you have new questions, so let's say question one, page one, question two, make sure you start at page two. Okay, so that don't start at page one. Because it will get messy for me to mark your answer. As always, don't forget your symbol and unit, because no symbol or unit equals to no marks. Okay, and don't forget to your names and ID on the answer sheet. Okay. Also, no books or allowed, but calculator. Okay, so I don't want everyone to get caught cheating or anything like that, because you will get straight fail for your marks or for your grade. Okay, so right, and number three about the questions. Okay, you will have um, 5 questions. Okay, 5 questions. You have to answer all. Answer all. The first question, 20 marks. The second questions, 20 marks. The third questions, 20 marks. The fourth question, 20 marks. And the fifth question, also 20 marks. Okay. So of course, under each questions, there will be sub questions, sub Q, okay? Sub question, and put here sub question. So it's all the same. Okay, there'll be sub questions. So which chapter will be in the final? Famous question from the students. All chapters, okay? Most probably it'll be combined, combination, combi. Okay. So just to recap what you've learned before, so everything, right? Series, parallel, series plus parallel, some definition, method. So in method, you have many things, right? What else? Ohm's law, what else? KCL, CDR, KVL, VDR, what else? You have to calculate voltage, maybe current, power. So you also have theorem that you've learned. What are the theorems? Um, Sorry, over here also you have what? Branch current, mesh current, what else? Nodal analysis. Mm, you have Thevenin, Norton, and you have inductor, capacitor, resistor. Okay, so basically all of this. Right? Any questions? Is it clear?
Yes, doctor.
Clear, Doctor.
Okay, if it's clear and there's no more questions, I think that's it. That's it for today. I wish you all the best for the final exams. I'll try to give your carry marks before your final exams, but I cannot promise because um, sebab tak berapa sihat lah. So if let's say saya sempat, saya akan I'll let you know. But if not, I'm sorry I could not give your carry marks as before the final exams. But anyhow, as long as you score in your final exam, you should be all right. Okay, so with that, if there's nothing else, inshallah kita jumpa. We will meet on Wednesday. I'll be there, inshallah, and I'll be the one who will be invigilating your final exam. Okay, so yeah. So with that, thank you very much, guys. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Salam. Thank you, Doctor.
Thank
Thank
you.
you, Doctor. Thank you, Doctor. Dia memang kelas. Thank you, Doctor.
All right, all right.
Alright. Okay.